We solved this question from Wassce, June 2007. It's an essay question from question number 4. And it says that two cyclists left a point P at the same time. The first cyclist covered 300 meters on a bearing of 296 degrees. And the second cyclist covered 250 meters on a bearing of 206 degrees. Calculate. Correct to three significant figures. A, the distance between the two cyclists, and B, the bearing of the second cyclist from the first. Before we start, if today is your first time on my students class channel, don't forget to subscribe and click the notification button so that you'll be promptly informed anytime we upload a new video. And hey, one more thing, click the like button so that the video can reach a lot of people. Thank you. Now let's continue. Now, when we say bearing, we mean direction, and bearings are measured from the positive y-axis in a clockwise direction, or the so-called geographic north. I'm talking about this. That is the y-axis, and of course that is the x-axis, and we call this part the geographic north. That is the the north, the south, the east, and the west. So talking about bearings, we are talking about the cardinal points, and we call this the geographic north. So if we are measuring bearing, we measure from here and we go in this direction, that is in the direction of the clock. So we say the clockwise direction. All right, so we have the question here. Let us try to put down the data and we'll look at how we can solve this. All right, so first we put down the data we have here. So we're saying that two cyclists left a point P at the same time. So let me sketch this, and it says that the first cyclist covered 300 meters. So let me look at the first cyclist here. So the first cyclist, we are told that the first cyclist covered 300 meters and the bearing was 296 degrees, and we had a second cyclist also. The second cyclist covered 250 meters and the bearing was 206 degrees. So if you look at these bearings, you can see that the first cyclist, if you look at the cardinal points or the Cartesian plane here, it begins from here 0, it goes this way 90 degrees, it comes down here to 180 degrees, then we have 270 degrees and comes back to 360 degrees here. So 296 degrees is going to lie in between 270 and 360. So that is to say that we will have the first cyclist living here. So we will have the first cyclist in the northwest direction here, and 262 is in between 180 and 270. So that is to say that we will have the second cyclist also in this direction. So let us see how we put this together. Let this be the point P that they will leave. So let me put the point P here. So this is my point P. So point P here. And let me draw my XY axis or my cardinal points here. So the first cyclist leaves on a bearing of 296. So as I did say here, 0, 90, 180, 270. So the first cyclist will be leaving on this bearing. So we have 296. So let us check it very well and see. Here's 180, here's 270. So 270, what should I add to 270 to get 296 here? Because I'll be checking from here, I'll be checking the bearing. I check the bearing from the north, so from here to here is 90, then I move on, there is 180, and then there is 270. So I want an angle here so that when I add to 270, I get a 296. So that is a very simple linear equation I'm going to solve here. So x is going to be 296 minus 270. So if I deduct 270 from 296, what do I get? I get 26 degrees. Yes, if you take 270 from 296, you get 26. So the distance here is 300 meters. I'm going to put 300 meters here. And the bearing is 296, so here is going to be 26 here. Let me extend this line a little bit so 26 plus 270, I get a 296. So that is the bearing of the first cyclist. Now I'm told that the second cyclist also lives on the bearing of 206. So 206 of course is found in between 180 and 270. So from here I have 90, 180, and so I would say 180. What should I add to 180 to get a 206? So that's going to be x equals 206 minus 180. So x is equal to 206 minus 180, and that is also 26. Draw the bearing of the second cyclist here, and the second cyclist to a is 26. So from here to here we have 90, 180, then plus this angle, that is 26. Then we get there 206 degrees for the second cyclist. But the second cyclist too has a distance of, or covered a distance of 250 meters. So here it's going to be 250 meters. All right, so you can see that the distance here is 300, and here too it is 250. So let me kind of reduce this a little bit here. Okay, so what is the question saying? It says that to calculate the distance between the two cyclists, so they all move from the point P and they get to certain points. I'm not told about it, so let me give some names to the points that they got to. So let us assume that the first cyclist moved from P and got to say a point, say A. Let me put the point A here, and the second cyclist also moved from the point P and got to a point, let me say B. So my question is that, or the question I have to answer is that, what is the distance between the two cyclists? So I have to connect point A, that is where the first cyclist got to point B, that is where the second cyclist got to. My job is to find the distance from A to B or B to A. But first, let me try to look at this plane figure very well. I have some angles here, and I should be able to find the angles that are found in between here. Now here is 26. So what is the angle here? That is, what is this entire angle? Now the whole of here, these are called quadrants, and each quadrant is 90 degrees. Each quadrant is 90. So the quadrant here that is in between the south and the west here, okay, here and there, is 90, but the angle here is 26. So what is 90 minus 26? That is what I should be looking at here. That is 64. So the angle here is going to be 64. So the entire angle here is going to be 64 plus 26. So what is 64 plus 26? And that is 90. So that is a right angle triangle. So I have a right angle here, and that makes the triangle here a right angle triangle. A right angle triangle is a triangle which has one of its interior angles to be 90 degrees. So to better show that, let me take up this and use the right angle sign to show that there is a right angle triangle. So I'll do something like this to show that this angle here is 90 degrees. So if I have a right angle triangle here, it means I can use Pythagoras to find the distance from A to B. Of course, this line from A to B faces the 90 degrees angle, so that makes this line the hypotenuse. So the hypotenuse length or side is the side that is opposite to the 90 degrees angle. So by Pythagoras, I can stick to this here. By Pythagoras theorem, the square of the AB, that is the length AB squared, is equal to the length AP squared plus the length BP squared. So I want AB squared, but I know AP squared. AP squared is 300. Oh, sorry, AP is 300. So I have 300 squared. And BP is 250. So I have 250 squared. And what is the square of 300? The square of 3 is 9. 2 zeros squared, I'll have 4 zeros here. And the square of 25 is 625. And 1 0 squared, I have 2 zeros here. So 1, 2, 3. So that is 62,500. And here is 90,000 too. So when I add 90,000 to 62,500, I'm going to get 152,500. And let me bring the AB squared here. So let me find the length AB. Finding the length AB means I have to take the square root of both sides to get rid of the squared. So I'll take the square root of this just to get rid of this squared, and because it's an equation, I have to do the same thing to the right hand side too. So this will cancel that, and the square root of this, let me pull out my calculator and type the square root of that. Alright, so that is said, you press on SD to get a decimal, and I have 390.51. Okay, so let me leave it there, 390.51 meters. But the question says that I'm to leave my answers to 3 significant figures, so that will be, I'll count 3 from the first non-zero digit, so 1 2 3, but because there is 5, I'll add 1 to this, and I will have 391 meters. So there is to 3 significant figures. So that's all. Now let's look at the B. The B says that the bearing of the second cyclist from the first. So the second cyclist from the first. So the key word here is from. From means that is where you stand to look at the bearing. So from the first, and this is the first cyclist. You know, the first cyclist moved from P to A. So because it is from the first, I'll be here. So what I want here, that is the first cyclist. So the bearing of the second from the first, I'm looking at this, the bearing of the second cyclist from the first. So I want the bearing from the north here to this line. So I want all the angles here. Let me look at it very well here. Now the first angle I can see here is this. In the first quadrant, this angle is 90 degrees. So that's the first one. So I have 90 here, then plus the angle here too. I have another small angle here. So let me extend this line. If I extend this line, I'll see it very well here. Now these two lines, they are the x-axis. So these two lines are parallel. They don't intersect. So on parallel lines, we have angles we call alternate angles. So of course, if you look at this line, I can extend this line through. So this line is called a transverse line, or it's called a transversal. So the angle here and the angle there are alternate angles. In other words, here too is 26 degrees. So if I want the entire angle from here to here, it will be 90 plus 26. So I'll add 26 plus another angle here, which I don't know. So I'm going to find this angle and I'll add it to this. So plus the angle theta here. Now let me look at how I can find theta. Now theta faces the side, and I know this side is 250 degrees, and of course I also know this side, and theta is also adjacent to this side. So theta is adjacent to this side and theta is opposite to this side. So using SOHCAHTOA, the trigonometric ratio I can use here is the tangent. We talk about SOHCAHTOA, and SOHCAHTOA simply means S is for sine, and the sine can be expressed as the opposite side divided by the hypotenuse side, and the C is cos. So we have sine here, and the cosine or the cos can be expressed as the adjacent side divided by the hypotenuse side, and the T is tan or tangent, and the tan means that we can express the angle in terms of the opposite side to the angle and that of the adjacent side to the angle. So in this case, I'm going to use tan here. So I'll write tan theta is equal to the opposite side. This side is opposite to the angle theta, so I'm going to write 250 divided by this side, which is adjacent, 300 meters. I'm going to write 300. The reason why I'm not adding the meters is very simple. If I add it here and add it there, they will still cancel. So you know, when you talk about ratios, they don't have units, because always the numerator and the denominator, there will be cancellation there. So if they have the same unit, and of course ratios have same units, so there is no need to put it there because you'll be cancelling if you put it there. So that is the reason why I just write 250 and 300. I don't add the meters because I know I will cancel. All right, so let me do some small cancellation here. 0 will cancel 0, 5 here 5, and 5 here 6. So I have tan theta to be equal to 5 on 6, and theta is equal to, I'll take the tan inverse here to get rid of the tan inverse of 5 on 6. So theta is equal to, let me pull up my calculator and type the tan inverse of 5 on 6. So tan inverse, you first press on shift and press tan. So you have tan inverse 5 on 6. Alright, then you press on the equal to sign. That we have 39.81. Let me put that away. So we have 39.81, sorry, 39.81. Okay, so that is the angle we have here, 39.81. So the angle theta is 39.81. So you have 39.81. So let me add these angles to find the bearing, or to get the bearing here. So I have 90 plus 26 plus 39.81, and there is a fraction, so let me change it to decimal. I have 155.81. so 155.81. But the question says I have to leave my answer to 3 significant figures, so I'll count 3, and this will be 1, 2, 3. But the next number is more than 5, so I'll add 1 to this 5, and that will be 156. So that is the correct answer, or that is how we can solve this. So there is a second way that we can solve this, and we can solve this question by using vectors. In the first method, we use plane geometry to solve this. So you can see that